Today we'll be doing the last set of notes for electron configurations. We'll be doing the shorthand notation, and we'll be doing some photoelectron spectroscopy. So here are our learning targets. We've done the first two. We'll be continuing those today, and then we're also adding in the honors learning target for this section here. So let's say we have an element like neon. If we want to do the electron configuration for that, we've done this before. We can use our blue chart. We can use the periodic table, however we want to do it. But we find out neon would be 1s2, 2s2, 2p6. Now, what we can do is called the noble gas shorthand notation. The way to do that is anytime we write out an electron configuration here, we are going to find the last full p orbital, and we can stop there. So you can see this blue line here. We can stop there, and we are going to shorten it because if we look at the periodic table, the whole periodic table here, everything in this right-hand column has a full p orbital, or it's full of electrons. So we'll call this the noble gas notation. So neon here is full. So what we'll do for shorthand is we'll be able to just use neon. And then our shorthand orbital notation, we'll use a noble gas for neon here, and we'll abbreviate that. This helps us when we do things on subsequent rows. So for example, let's say I have magnesium. Magnesium's electron configuration is 1s2, 2s2, 2p6, 3s2. So again, I'll stop at the last full p orbital here, so 2p6. I'll stop there, and I already know 1s2, 2s2, 2p6 is neon. So we saw this top example here. That's the electron configuration for neon. So if I want to write out magnesium's configuration quickly, I know this first section is already neon here. So what I'll do is I will say neon, and neon here replaces 1s2, 2s2, 2p6. And then all I have to write is the part that magnesium adds on to neon, which is 3s2. So when I write neon in brackets here, or Ne in brackets, that means use the electron configuration for neon, and then just add on what makes it magnesium, and that's 3s2. And then if I want to do the orbital notation, I would do the same thing, and then I would only have to do the blank with the up arrow and down arrow for magnesium to show 3s and its 2 electrons there. If we look at another element like sulfur here, the way to write its electron configuration, if we come back and look at the periodic table here, so sulfur is down here on the periodic table. The way we can do this quickly is we look at the row above it. So here's neon. So what I'm going to do is write neon, and then that saves me from writing 1s2, 2s2, 2p6 here. So I go to neon right away, and then I just go across the third row to get to sulfur. So I'm going to say neon, and then 3s2 for these two, and then 2 or 3p, 1, 2, 3, 4 to get to sulfur. So when I write that, I have neon, 3s2, 3p4. So just writing neon here saves me writing out the first couple rows. And then we can also do valence electrons right away. Remember, we just look for the highest number. So the highest number here is 3, and it shows up in 2 spots, so I have to add these 2 electrons together. So 2 plus 4, sulfur has 6 valence electrons. And then orbital notation, same thing. I do my neon shortcut, and that saves me from writing the first couple things here. So 1s2, 2s2, 2p6. And then I can jump to 3s and its 2 electrons here. And then 3p, remember p just gets 3 blanks. And then I have its 4 electrons. So I need to add them 1, 2, 3, and then I double up the first blank. And I get that 1 spin down electron there. Our next example is cobalt. So take a moment, you can pause the video here and try to do cobalt on your own. All right, if we look at our periodic table, here is cobalt right in the middle. So what we're going to do is go to the row above it, find the noble gas at the end, that's argon. So I'm going to start my notation with argon. in brackets, and then that saves me writing out all of the configuration for the first couple rows here. So I'm going to say argon, and then I just need to do 4s here for these two, so 4s2, and then 3d 1, 2, 3, 4, 5, 6, 7 to get to cobalt there. So I do argon, 4s2, 3d7, and then valence electrons again right away. Highest number here is 4, so highest energy level is 4, 2 electrons in it. So our valence electrons are 2. And then orbital notation, I can do my shortcut with argon again, and then I just have 4s with its 1 blank and its 2 electrons, and then 3d, d remember gets 5 blanks, and then I just fill in the 7 electrons. So I would go 1, 2, 3, 4, 5, and then come back here, 6, 7. So this is it for the shorthand notation. Remember, we're just using the noble gas. That is the thing on the row above it on the far right side here. That saves us from writing everything that comes before. And all we have to do is look at the row we are in and then just fill in whatever 4s2, 3d7, like in the cobalt example. All right, from here we move on to photoelectron spectroscopy, also called PES. It's just a technique chemists use to gather information about electrons in an atom. They shoot the atom with photons. Some of those photons get absorbed, remember from the beginning of this unit, and then we get electrons emitted. Then they look at those electrons, see how much energy they have, and that tells us, or tells the chemist where the energy levels are and where the electrons in the atom are located. So here is a PES chart here, and it tells us on the y-axis the number of electrons, and then it gives us energies here on the bottom. So what this is telling us is at the start, this is where the nucleus is located, and then we'll see spikes in our graph at increasing energy levels. Each spike tells us how many electrons are at each energy level. So as we go to the right, the energy levels just increase. If we look here at the PES graphs for hydrogen and helium, here is our first one on the left for hydrogen. So hydrogen has a spike here that spikes at 1 electron, and since it's the first spike that pops up, that means it is the 1s orbital. So the 1s orbital has 1 electron in it. So we would say this just means 1s1. If we compare that with helium, helium here has a spike at 2 electrons, and the first spike here represents the 1s orbital, so that just is 1s2. So we're just counting spikes, and we'll see multiple spikes in a second here, but this first spike that shows up is the 1s orbital, and then you just look how high it goes. So hydrogen, it's going up to 1, so that's why it's 1s1, whereas helium, taller spike, just means 2 electrons. Here, if we come back to helium, we already saw this one, so we know that's 1s2. If we compare that with lithium, now we see multiple spikes. So the first spike on our graph here remembers the lowest, that represents the lowest energy level, which is 1s, and it spikes up to 2. So that one is 1s2. And then we have a second spike here. Remember, the second energy level up is then 2s, and it spikes at 1, or it goes up to 1. So that one would be 2s1. If we move on to something with even more, here we look at it, first energy level spikes at 2, so this is 1s2. Then second energy level is 2s, again it's 2, so 2s2. And then our third one, so after 2s, remember, comes 2p, so this is 2p, 1, 2, 3. So the last one is 2p3. So if I want to identify this element, its configuration is 1s2, 2s2, 2p3. If I look at my periodic table, 2p3 is 1, 2, 3. So here's 2p3, it's nitrogen, because it's the third one in the 2p row. So that is nitrogen. And we can do one more. Again, pause the video here and try to do this one on your own before unpausing. If we look at this one, first energy level here, this is 1s. It's at 2, so 1s2. And then same thing, 2s2. And then remember we have 2p next, and it goes 1, 2, 3, 4, 5, 6. So 2p6. And then our last one is 3s1. So here's our configuration. And if I go back to my periodic table here, 3s1 is right here, sodium. So 3s1 would be sodium. So this element is sodium.